Today I'll be talking to you about forensic brainwave analysis, which is also known as brain fingerprinting, and how we can use this technique to solve crime. Basically, forensic brainwave analysis is the use of the P300 brainwave, which is measured through an EEG in order to solve, or in the court of law, to solve crime. And today I'm going to be telling that story through the tale of two miscarriages of justice. On the left there you can see Terry Harrington. He's an American citizen who spent 24 years of his life in prison for a crime that he didn't commit. And on the right is Tina Pora, a New Zealander who spent 21 years of his life in prison for a crime which he also didn't commit. Forensic brainwave analysis was used to help free Terry Harrington from that particular nightmare, and I believe that had it been used in the case of Tina Pora, it could have prevented him from being a suspect right from the beginning. So how does all this work? Well, this is what the brainwaves look like, and these squiggly lines were the lines that we used to help free Terry Harrington from his 24 years in prison. So essentially, there are three kinds of information. There are the probes, which only the perpetrator or the person who is at the scene of the crime could know. Then there are the targets, which are the blue line here on the screen. Apologies. The blue line is the probes, the red line is the targets, which everybody knows. So if we're in this room, then let's say that there's a drawer over in this table over here. Inside that drawer, there's something that only one person in the room knows about. So I could leave the room, I could have you look in the drawer, and that one person I would then be able to identify using the brainwave technique. However, I could also ask questions about what was outside the window, for instance. And everyone in this room would know the answers to those questions, so they would be my targets. And the third type of information is irrelevance. So irrelevant information might be a picture of a baby seal in Alaska, or a polar bear, or a lion. Stuff that is information which is completely irrelevant to the question of who knows what's inside that drawer. In the case of Tina Pora, it could be a question of what the murder weapon was. It could be given options of a gun or a knife or a baseball bat, or a softball bat rather. In fact, the right answer is a softball bat, so you only get this aha response, which is the peak, which matches with the target response in cases where you know the significance of the information being presented to you in the context. And so in Harrington's case, this graph demonstrates that information is present in his mind that he could only know if he was at the scene, or that he could only know if he was where he said he was. This is in fact his alibi situation. So he said at the time that he was at a baseball game, and this information here shows that this line here, the blue line, matches closely with the target, demonstrating that in fact that information is present in his mind. But when they tested him with details of what was present at the crime scene, this is the result that he got. So you can see that the blue line is the probe, information which he would have known if he was at the crime scene. And the red line is the target, so that's information which he is known to know. So he gets a recognition response for the target, he gets that aha response, but the blue line simply flat lines. And that flat line demonstrates that information that he would have known if he was at the scene of the crime, was not present in his brain at the time. So this was Harrington's get out of jail card, if you like. Because Harrington took this test, this evidence went before a court, and because this response is involuntary, because it occurs before it's able to be suppressed by the conscious mind, in fact, the court was able to say that Harrington was not at the scene of the crime, that he did not commit the crime, therefore, and that he was wrongly imprisoned. However, if we compare this to something like the machine on the right, then this is in fact a polygraph machine. And the polygraph machine is vastly inferior to this technique, and there's a good reason for that. The reason is essentially that the polygraph machine does not measure whether information is present or absent within the mind of a person. Instead, it measures stress responses and infers from that somebody is lying. Now that's a far less direct inference, because especially when they're being interrogated about something like a murder, there are a vast number of reasons why someone might be stressed. In fact, the average person in that situation will be considerably stressed. And that's why this P300 headset here is a far better way of measuring not whether someone is lying, but whether information is present in their mind or whether it is absent. And from that we can draw a far more direct conclusion about whether or not they were in fact present at the scene of a crime. So this has the potential to revolutionize criminal trials. It has the potential to speed up investigations hugely by allowing the police to rule out suspects early on in the process that otherwise would not have been able to be ruled out, that otherwise would have been subject to questioning of witnesses, an incredibly unreliable way of actually ascertaining who was at the scene of a crime. So where to from here? Well, this is the day that Terry Harrington was released. And I believe that we can have more days like this, and fewer days where people become falsely imprisoned. In 1953, DNA first burst onto the scientific scene, but it wasn't until the 1980s that it actually made it into court. I hope that it's not that long before, not 30 years before this technology allows us to see more scenes like this. Thank you.